The next one is a really interesting one about Spotify, because Spotify has changed the way that we listen to music forever. So how did they do that? Using machine learning to customize everybody's home screens. And also, even more important, how have they been doing that and really experimenting rapidly? We will hear about this from Ching-Wei Chen, engineering lead, home personalization from Spotify. So please give him a big, big round of applause.
Thanks a lot. Thanks. Very happy to be here. My name is Ching-Wei Chen. I work at Spotify in New York. And today I'm going to talk about experimentation and open research at Spotify. So I'll start out by saying fast. And what do I mean when I say fast? And it's not this picture. It's not a race. What I'm talking about specifically is, in my company, we're trying to deliver value to the user, our listeners. And so if we clearly define what that value is, what can Spotify do for the listener, once we have that concept of value, we want to be able to test and evaluate hypotheses as quickly as we possibly can. And this doesn't mean that they're all going to work. Some are going to fail and some are going to succeed. But we want to be able to test things as quickly as possible. We actually want them to fail as quickly as possible so that we can learn, we can come up with the next hypothesis and test again. And all the while, we deliver incremental value to the user. So this is what I mean by learning fast. And similar philosophy can be found in a lot of systems that we're all familiar with today, with lean principles, agile, microservice development, and CI/CD. It's all about trying to take the smallest logical steps and learn things as quickly as possible so you can iterate quickly and deliver value quickly. So at Spotify, we're optimized to move quickly from the organization of our company. We're organized in lots of small autonomous teams, and each team has full ownership over a particular part of the app or part of Spotify's business. And so you can see here, in my area, we deal mostly with recommendations and user engagement, how we give people satisfying listening experiences on Spotify. And so each of these things you might have touched in your Spotify life before. There's search when you're trying to look for a particular song or artist. There's your Discover Weekly, which is a weekly playlist with new songs for you to discover. There's radio stations to listen to music, never-ending listening sessions. And there's also something in the corner over there called the home screen. That's what I'm going to focus on today. So home is the default screen in the mobile app. And that means every one of our 191 million users around the world see this screen when they open up the app. And we want this to be the place where we show the user the best that we have to offer. So it's going to be everything from new releases to personalized recommendations, podcasts, and personalized playlists. And everything should be personalized so that you get the best stuff for you. But as you can imagine, we have a lot of content on Spotify. We have over 40 million tracks, we have podcasts, we have playlists. And so this choice can sometimes be paralyzing. If we were to just dump all that in home screen and make you scroll through everything, you'd never get anywhere. Also, people don't scroll that much. So my job and my team is to try and find the best stuff for you and put it on the top of home, or put it on the front page of home. And to do this quickly, we use machine learning to understand what the users like to listen to, when they like to listen to it, how they like to listen to it, and surface it in the right place at the right time. And so that's a little glimpse of all the different content that we have on Spotify to put on home. So back to machine learning, the task we have is, if I'm formulating this as a machine learning task, given a certain context, and by context here I mean a combination of the user, everything we know about the user, what they listened to in the past, as well as what time of day it is and where you are and those kinds of things. So context, given context, given the content, and we divide them up into these two dimensions. One are shelves, and each shelf has a number of cards within that shelf. So we've given context, given a card, and given a shelf. What we want to do is we want to predict this kind of the reward or the value that we're giving to the user. There are many different kinds of rewards, reward metrics we can use. You could imagine when somebody plays a song from something we put on home, that could be a reward. And so we're trying to, again, predict the reward based on the context and the content. So we can use lots of different types of machine learning techniques to help us do this. But this is a tricky problem because you have data sparsity. Like I said, we have a lot of content, and most users aren't going to have a chance in their lifetime to listen to every single thing on Spotify. And so the data is very sparse. And we also have what's called presentation bias. So because the homepage is already personalized, what you see there has already gone through a machine learning algorithm. And so you see more of what the algorithm recommends, and you may click more on those things. So we don't get to learn from things that we haven't had a chance to expose you to yet. And that can be a really bad thing. I mean, we don't want to just recycle the same 10 playlists for everybody. We want to expose the large world of content that we have at Spotify to the user. So we use a technique called Contextual Bandits to help us kind of explore the library while also trying to keep the user happy. So there's a paper that we presented at Rexis this year if you're interested in learning more about that. But I'll try and summarize it very quickly here. So Bandits is this approach where you think about slot machines in a casino, and you're pulling slots. They're called one-arm bandits. And the idea is that you try to balance exploitation and exploration. So exploitation would be if you know that one machine is paying out higher than the others, you kind of want to pull that one a little more often, but you don't really know so much about all of them, and really, your accuracy on how much they pay out is not going to be that high anyway. So you have to keep playing some ones you've never played before, but you do know some things, and you want to maximize sort of your overall return. So that's kind of the formulation that we have for the homepage as well. In our case, the policy is sort of what are we going to put in this position on home, and that's going to take into account a couple of things. So there's the exploration strategy. That is sort of what I'm talking about. Like, so how do we balance between what we know is going to be good for the listener, what we know that they're going to enjoy, versus, well, they've never listened to this before, or we don't have much data on it, we're not very certain. And so we need to put it out there to some time so that we can get more data and learn from it quickly. And there are different strategies for doing this. The policy is also going to be driven by the reward function. And so the reward function is, like I said, it could be clicks, it could be plays, it could be follows of an artist, or kind of downstream interactions. So how do we measure, how do we judge like the satisfaction of a user when presented with that content? And there are many different techniques and algorithms that you can use to model this reward. And then the action set. So that's sort of the world that you play, all the different options for the policy. In our case, it's going to be cards and shelves. If we go back to sort of this concept of the reward and how we model that, it's based on the context and the content, which is cards and shelves. Let's see. So the context contains a lot of things. It contains everything we know about the user. Contains everything we know about the situation. It contains everything we know about the content itself, and even includes like how we present it to the user, the UI. So how big the picture is and what words we use, whether the text is like aligned right to the right or to the left. So all these things that we can play with are all variables, and when you have that many variables to play with, you need to do a lot of experimentation. So the traditional experimentation process, you might have an idea, and you go and you develop some things, you do some research, and you try and find something that might work. And then you, so for example, in our case, if we're trying to find the optimal policy, we could play around with all those variables, different algorithms, different reward functions, different action sets. So we could, introduce new cards, new types of playlists, or new categories and groupings of playlists. So all those things are things we can experiment with in the research world. But to actually know if we're doing the right thing, if we know to know whether the user is going to be happy with it, we have to put it in front of them. And so, kind of the classical model would be to put this out in an A/B test in your app. And so depending on the test requirements, it could take a couple days, could take a couple weeks to do an A/B test, and you can run many of them at a time depending on how many users you have or how many users you need. But if you put together deployment time, put your research code into deployment, and then the time to run an A/B test, we can be pretty quick, but it's still, you can count on a couple hands like how many experiments you can run in a sprint. So I'm going to talk now about a tool that we use for offline evaluation that helps us speed up this experimentation process. And so it's a little step that sits in between the research phase and the A/B test. And we can do it completely offline. So this is all limited by compute power and memory power. And we can do this at a scale 100 times more than what we can do for A/B tests. So the ML Lab, this is brought in with an acquisition we made in 2017 of Nyland. But we have a tool internally that we use, and it's always changing. But it's an offline evaluation framework, and it does everything from launching tests, evaluating your experiments, and archiving your studies, so that everything you do as a researcher is reproducible and shareable, so other teams can pick it up and see what you did, test on the same data set that you have. It's broken up kind of into experiments and evaluations. So the experiment, it's kind of a thin wrapper layer around whatever code you have. Usually your machine learning model. And then the evaluation defines a data set and an evaluation metric. And those things are stored on a server, and you can run your thing over and over. It can do grid search and hyperparameter optimization for you. And all this put together, you can, I think having the standard data sets and evaluation metrics are something that lets you just try whatever you want and then throw it up into ML Lab and see your results. So we have sort of a leaderboard kind of feature where you can see for a given evaluation all the different people who are submitting models to fit that evaluation and how they scored, and you can kind of see what's working well, what's not. Very briefly, it's a developer tool, so it integrates into the developer's workflow or the researcher's workflow. It's an API, and there's a command line interface where you basically, again, you put a couple of YAML files in your project directory. It's a little bit like Git. You check it into the ML Lab, and you can actually run it on. It'll run your jobs on workers for you. And then there's a dashboard interface that I just showed before, where you can kind of see the results of your evaluations and other people's evaluations. One thing to note, because we've introduced this extra layer between the research and online A/B tests, the metrics are never the same. What you can test in an offline manner are not going to be the same as what you test online. Online, you might be testing for how long they played, or even retention, these kinds of things that you can't easily test offline. And so you have offline metrics that maybe are more easy to compute. And so you have to continually correlate these offline metrics with your online metrics. And so in this case, you've got offline scores of different algorithms in the different colors on the x-axis. And on the y-axis, these are the online A/B test scores. And hopefully you see some kind of correlation so that you know that you're testing with the right metrics. So that was experimentation process. How am I doing on time? the clock is 10 minutes? Okay, cool. So I'm going to switch off a little bit and talk about speed again. But speed, everything I talked about before is kind of some of the things that my team does at Spotify to learn fast, to work quickly, and experiment quickly. But we also try to work quickly both inside and outside of Spotify. And what I'm going to talk about is how we do outreach to the greater community. And so that's like the research academia community and developers like yourselves, and even hobbyists and people, other people in industry as well, industrial research. We've now done a couple of projects with open research. We've hosted a couple of data sets of Spotify data, and we've hosted a few data science challenges. And we really hope that this can, number one, like engage with the community, the research and developer communities, and get us involved and get them in touch with us as well. But also by putting these interesting questions out there that we are interested in, and putting it out there, we can again multiply the number of ideas and thought that goes around these problems. And it's not just for us; it's for increasing the body of knowledge in the whole world, like for everybody. And some data sets, you're familiar with, ImageNet, CFAR, and MovieLens, are famous now because they basically sparked whole areas of research and whole areas of technology development. So the first one of these that we did was earlier this year in conjunction with the Recommender Systems conference called Rex's Challenge, and the challenge was around automatic playlist continuation. So we have a feature on Spotify called Recommended Songs. So if you create a playlist in Spotify and you add a couple songs to it, you might give it a title. We can actually recommend songs that will go in this playlist for you. You might run out of ideas after 3 or 4 songs and like, oh, I'd like to listen to this playlist, but I don't want it to stop after 4 songs. So we have this recommended songs feature, which is very closely aligned with this challenge. So the data set we released was 1 million playlists from Spotify. And the challenge was for a test set where we've hidden some of the tracks to predict all the tracks that fit in that playlist. We had great response. We had thousands of participants from lots of countries, and hundreds of teams and over 1,000 submissions. I'll make a quick note here. This is the distribution of all the different countries. And Austria came in number 2, so thank you very much. I hope to see this number higher. And this was a great experience for everyone, myself included, because everyone took a different approach to it, a different angle to the problem. There was everything from neighborhood-based methods to random walks. There was autoencoders, LSTMs, like sequential modeling, and ensemble methods, and all kinds of different methods. If you go to 2018.rexeschallenge.com, the top 10 submissions are all there. The papers and code actually are all there. So part of the challenge and part of our open research philosophy is that it's not open unless people can see what you do. And so as part of these challenges, we always have the submissions come along with a paper submission as well as open source code. So there's lots of interesting things, and this was just the first time we did it. As we get this data set out there, as people start to use it over the years, we expect that some of these will work better than others, and it could be a really interesting area of research. That challenge wrapped up already, but if you missed that one, you're in luck because we're running one right now. It's in conjunction with the Wisdom conference that's happening next year called the Wisdom Cup 2019. And the task this time is sequential skip prediction. So we've released a data set of 130 million listening sessions from Spotify all properly anonymized and cleaned up. But it also has the associated interactions to go with them, whether they listen to them, roughly how long they listen to each song, and whether they skip them. And then the task is going to be, again, for a given test set, we just give you a separate set of listening sessions, and the task is to predict which of the songs a particular user is going to skip. And again, we don't know where this is going to go. Some of us have thought about this within Spotify before, but there's again a whole world of researchers and developers out there who are probably really curious about this too. So we're putting it out there, and we are really looking forward to seeing what the community comes up with. So you can go to this link and sign up today. It runs until January, so I hope to see many of you in this room maybe sign up for this. So if this timer is right, I might have gone too fast, but I'm going to summarize, and then we can do some Q&A, and I'm happy to go back over some of my slides. But to summarize, we at Spotify, we use machine learning to help us learn about our users. So what they're going to enjoy listening to at any given moment. And my team also uses this. And in addition to that, we have experimentation tools and offline evaluation, and that has really helped us multiply the amount of experimentation we can do. And then going even beyond that, sharing data sets and open research are ways for us to kind of expand the pool of ideas, not just for us, but for the field. So there is no speed limit. This is not a race. But what we at Spotify want to do is we want to make sure we're always accelerating. And so we try all these things, we make them better. And we need people like you all to help us learn even faster. So you can go to spotifyjobs.com and see if we have the right role for you, or you can come talk to me, or my colleague Damien is here for the Congress. Yeah, and you don't all need to be one-armed drummers. We take other instruments and other people as well. So I'd like to thank everyone. Thank you to WeAreDevelopers for inviting me here as well. I'm happy to take questions.
Thank you. All right, perfect. Thank you, Ching-Wei, really, for this amazing talk. And we already have a lot of questions on Slido. You get to choose
Actually,
which ones you would like to answer.
The Slido guy, he mentioned there was going to be a question at the beginning for you. Maybe it didn't make it through. So I want to ask, maybe by raising your hand, can you show me which of you have participated in a data science challenge before? Cool. Less than 50%, but more than, maybe 20%. All right. Thanks. Okay.
Oh.
Oh, there's a poll. Thanks.
Cool.
All right.
Can we go back to the questions?
Thanks. Okay.
Let's choose, let's say, 3 questions that you would like to answer.
All right. How do we know that the ML results on home screen are good? For me, there's always same at the top, and I have to scroll a little up. So we look at how people respond to the stuff on home. So we log whether we show, what we've shown users. We log what they've clicked on. We log, whether they've listened, how long they've listened, whether they come back and listen. And we feed all that back into our machine learning model. And if we're doing our jobs right, we're hopefully able to do well. On a personal level, it's hard to answer without seeing your home screen or your username, what's going on there. I don't know. Contact me, and maybe we can look into it. I'm not sure how to answer that one.
Perfect. Okay, second question. The one on top, is that all right?
Let's see, I've been using Spotify.
I've been
Are they
using
all gonna be-
Spotify for several years now, and I still get recommendations for artists. For example, Drake from the genre that I never listened to, ML Issue or ads.
I want to address this. I think it's not an ad. I'll say that. But yeah, we want this as well. Let's just say that. So this is exactly what my team wants. And there are going to be promotions of things on Spotify for artists that are really important or really I don't know, special in world culture, let's say. But we don't want that to go, just sprayed on everyone's screen. I think the idea, is the same as what I said before. We want everyone to have, the best experience on Spotify, and so we hopefully can target the people who are going to enjoy those kinds of promotions. And not show it to people who may not like it as much, or maybe it's going to be in a different position for people who may not enjoy it as much as other people.
Perfect. I think the next question is also interesting because I've also wondered this a lot. I think it's basically asking what is in the black box. So if I like a song, will Spotify recommend me a similar one based on a genre? Or is it beats, year of production? What are the factors?
Yeah. Well, if I go back to, I don't need to go back to my slides, but so the thing you need to understand about Spotify is we're not just one feature. So when you say Spotify recommend me, we recommend things in a dozen or dozens of different places, everywhere from the homepage to the search bar to when you make a playlist. All these different, they're all recommendations, and they're all using different signals. So some of them might use genres more than others. Some might look at the beats. Some might look at your interactions or other people's interactions over time. So it's impossible to say for a particular unless I have a particular use case. Sort of what goes into recommendations, but we take it all in and we use the best features for the given use case.
Perfect. So I think that was it. And because we don't have enough time to go through all the questions, please find Ching-Wei outside or come up to him and ask him questions. And really, thank you again. And we will begin again at 2:45 on the dot.
Thanks very much.
We'll see you at the panel discussion. Thank you.